Hello. Welcome to this lesson on energy transfers. In our lesson today, we will begin by understanding the concept of energy transfers. Following that, we will explore different types of energy transfers. You are already familiar with the principle of conservation of energy, which states that energy cannot be created or destroyed, only transformed from one form to another or transferred between objects. Building on your understanding of conservation of energy, we can now delve into specific examples of how these energy transfers occur. This will advance our comprehension of how various physical processes work, enhancing our overall grasp of physics. As you will recall, energy is neither created nor destroyed. It simply changes form or moves from one part of a system to another. Understanding energy transfers helps us explain and predict how different processes work in the natural world. This knowledge will help us to explore how energy is transferred in both open and closed systems. In both open and closed systems, energy can be transferred between different objects. Consider a row of dominoes lined up in a closed system. When you push the first domino, the falling domino transfers its kinetic energy to the next domino, causing it to fall. This process continues along the row. In this closed system, the total energy remains constant. Energy is transferred from one domino to another without any loss to the surroundings. The system's energy is conserved, demonstrating that energy moves between objects within a closed system. In an open system, such as a room with a heater, the heater transfers electrical energy from the power source into thermal energy, warming the air in the room. Energy is not only transferred within the system, that is the air in the room, but also interacts with the surroundings. The heater emits heat into the room, and some energy is lost to the outside environment through walls, windows, and ventilation. Energy can also be transferred by changing from one form to another. This can occur in both open and closed systems, though the context can affect how energy is exchanged. Take the closed system example of boiling water in a kettle. When you use an electric kettle, electrical energy from the power source is converted into thermal energy by the kettle's heating element. The thermal energy is then transferred to the water, causing it to heat up. In the idealized version of this closed system, the energy transformation happens entirely within the kettle, and no energy is lost to the surroundings. An open system example could be a car. Chemical energy from fuel is converted into kinetic energy and thermal energy that dissipates into the environment. The car operates in an open system, where energy transformations involve exchanges with the surroundings. Some energy is lost as heat to the exhaust and engine components, highlighting the interaction with the environment. Energy transfer can happen through four pathways: electrical work, heating, mechanical work, and radiation. We will explore each of those pathways in detail in the upcoming lessons. In today's lesson, we delved into the ways energy transfers occur between objects, forms, and systems. We discussed real-world examples like falling dominoes, boiling water, and heating a room, illustrating how energy remains conserved even as it transfers or transforms. By understanding these energy transfers, we can better explain phenomena in everyday life and solve related physics problems. In summary, today's lesson provided a foundational understanding of energy transfers and conversions, crucial for grasping more complex concepts in physics.